Good morning everyone. Today we are going to discuss some of the questions based on motion in a straight line. Here is a problem which states that a particle starts from 0, 0 and moves along y-axis to a point of 0, 26 and then comes back to 0, minus 26. We need to find the ratio between the distance and the displacement. In the figure, we can see that a body is moving from 0, 0 to 0, 26 and it's returning back from 0, 26 to 0, minus 26. So the distance will be equal to, let's give some names to the points O, A and B. To take the distance, we take OA plus AO plus OB. Distance will be equal to, again distance equal to 78 meter. Find the displacement. We know that a particle is moving from 0 to A and it's returning back from 0 to A to 0. So at that time our displacement will be 0 and we take from 0 to B as this is negative direction. So we take minus 26, which is displacement, we got displacement as minus 26 meter. Here we need to take the magnitude of displacement. Which is equal to 26 meter. So the ratio from distance to displacement is equal to 78 divided by 26 meter, which is almost equal to 3. Let's go on to the next question. Here, displacement S of a particle is given as S is equal to A sine omega t, and we need to find the acceleration of the particle, and they are also given as A and omega are constants. We all know that change in displacement with respect to time is given as velocity, and change in velocity with respect to time is given as acceleration. So let's differentiate S with respect to time. So we get ds by dt is equal to A is constant, we keep like the same way. Sin omega t can be written as cos omega t into omega. So we got V is equal to A into omega into cos of omega t. So again differentiate S with respect to time. So we get d square s by dt square is almost equal to A is constant, omega is also constant. If we take the differentiation of cos omega t, it's minus sine of omega t into omega. So we get acceleration is equal to d square s by dt square, which is equal to A minus A omega square sine omega, which implies acceleration of the particle is equal to minus A omega square sine omega t. Here option 1 is the correct answer.